All right, big jump from, what was the last chapter, 8? So we're skipping 9, 10, 11. Must be good stuff in those chapters. But we're at the end of the year. I want to fit this in. I want to make sure we have time. I'm not sure if it's going to take the whole rest of the year to do this, but at least we have enough time to finish it. So that's what I would like to do. All right, so that's why we're skipping to this, because I think it's important, especially in Algebra 2. You should definitely be doing this in Algebra 2, and I want you to be prepared for Algebra 2. So when you see it, you're like, oh yeah, that's right. That's that stuff we did at the end of the year last year. Okay, that's what I would like you to say. Whether or not you remember it, at least it was in your head. At least you recognize it, and I think it's important to do. All right. So, we've talked about this before, but they call it trigonometric. That's a fancy name, isn't it? Trigonometric. It's taken from a word called trigonometry. Oops. Trigonometry. Yep. All right, so that's the word right there. So that's the study. That's the course, I guess, you could take. There's classes you could take that's just called trigonometry. I don't think they're as common as they used to be. It seems like back in the day, they had courses that are called trigonometry, but it seems like they're kind of mixed in with other stuff nowadays. I don't know if that's true or not. That's just the way that I think that's happening. But anyway, we can shorten this. What's a good way to shorten this? Just trig. That's right. So a lot of times we just say trig. All right, just a lot easier than saying trigonometry. Or instead of trigonometric, which is kind of a cool word, but trigonometric ratios, we would just say what? Trig ratios, all right? What is a ratio? If you were to explain to somebody what a ratio, compare one number to another. I like that, okay? So if you compare one number to another, that's a ratio. We've done ratios before, like this, 3/4. It's a fraction. We obviously know that, but it's a ratio. They also call this a rational, oops, what's going on here? There we go. It's called a rational number. Have you heard that before? Why do they call it a rational number? Why do they call a fraction a rational number? Because of what? Ratio, exactly right. Look at that word right there. And that word rational is the word ratio. What's a ratio? It's a comparison between two numbers. So what a fraction is, you're comparing 3 to 4. Okay? Everybody got that? All right, enough of that. So we dissected the word trigonometric and we dissected the word ratio. So now let's do this. So when we do these trig ratios, when we do trig, well, not all trig, when we do these trig ratios, I'll say that, we are only dealing with right triangles. Okay, so these only work with right triangles. All right, so it's really important that you understand that. We will do stuff, I don't know if in this class we'll do it. I'd have to look ahead in my notes. I can't remember off the top of my head. But at least in Algebra 2, you're going to go beyond right triangles. We may even do that this year. I just can't remember. All right, but for right now, anyway, we're just going to deal with right triangles. All right, so what do we know about a right triangle? 90 degrees, that's right. You got one 90-degree angle or one right angle. So let's draw a right triangle. All right, so you got one right angle. Let's label some of these sides right here. There's one side that I can label right off the bat. What would that be? That would be the hypotenuse, okay? And which one is the hypotenuse? Let's use another word instead of across from. It's an easy word. It's not a fancy math word or anything. Instead of across from, it's nobody? Opposite. Very good. It's the opposite the right angle. So this side right here, this slanted one right here, is opposite the right angle. So we call that the hypotenuse. There's a reason why I wanted you to say opposite. You could say across. It works. I completely understand what you're saying, but there's a reason I want you to say opposite. Okay. So you've got a hypotenuse here. Now, I can't really name these two. Now, we could call them the legs of the right triangle, and that's fine, but that's not what we're going to use right now. What I'm going to do is I'm going to label this angle right there. It's an angle that I don't know, okay? I don't know how many degrees it is. I'm not going to call it triangle ABC or anything like that. But what have we learned just recently that we call an unknown angle. What do we label it as? Theta. That's right. So I'm going to call this theta. Is that all right? I could have called this triangle ABC, and whatever letter here, I could have said that this was angle A or angle C or angle B or whatever, all right? But a lot of times in math, we use theta. I just want you to get used to it. I want you to get comfortable with it. Again, it just means it's an unknown angle. Everybody with me on that? Okay, so what we're going to do is now I'm going to label the other two sides with this angle, okay? In relationship to angle theta, what is this side and what is this side? Let's do the vertical one, the one up and down, okay? We already said it, but what is this side in relationship to this angle theta? It's opposite, and that's what we're going to call it. We're going to call it the opposite side. I'll just put OPP for opposite. Is that all right? See, back about 20 years ago, maybe more than that, if I said OPP, kids would all break out in song. Did you know that? There was some song, it was not the kind of music that I'd listen to, but something about OPP. I don't even know what that stands for. Who knows? That could stand for something bad. I'm saying it. I have no idea what it means. Nobody's heard that song? Like, what about OPP, you know me, and blah, blah, blah. I don't know, something like that. Nobody's heard that song? Anyway, it was way back. It was back in the 90s, so that's what, 30 years ago now. Not 20, so probably 30 years ago. All right, anyway. So, opposite. Now, here's a word. You probably heard this before. You probably wouldn't use it in everyday language. But this side right here is the one that's next to this angle theta. It's the adjacent. And you watched my video yesterday, didn't you? You probably heard it. It's the word adjacent. I'm just going to put A-D-J, all right, for adjacent. I'll spell it for you. Adjacent. Kids would rarely use this word adjacent, but if you listen to old people talk sometimes, like if you live next to somebody, right? You have a neighbor. You could say, well, their house is what to my house? Is adjacent to mine. Have you heard anybody say that before? Maybe not. But now that you've heard the word, now you're probably more likely to hear it, all right? You might hear somebody say something is adjacent to something else, all right? Because that's old people use words like that, all right? So now we can use words like this. Well, I'm already old, so anyway, adjacent. It means it's next to it. Well, what about the hypotenuse? The hypotenuse looks like it's next to this angle, but the hypotenuse is just the hypotenuse, right? The hypotenuse is specific. What is it specifically? We already mentioned it once. Say it again. Hypotenuse is always what? Opposite the right angle. So the hypotenuse is always going to be the hypotenuse. Everybody understand that? Okay. The opposite, it all depends which angle you're talking about. What if I use this angle up here? I'm trying to think of another Greek letter that we could use that would represent an angle, and I'm blanking right now. But let's say we use this angle right here. We'll call this angle B. We'll call it beta. It's a beta is kind of a B, but then you like kind of come out a little bit more. That's weird. You've heard of that, right? Alpha, beta, yep, gamma, all these different Greek letters. All right, so we'll call that beta. So now, watch this. Is this now adjacent to angle beta? No, this one would be what? This would be opposite to that angle. So it all depends what angle you're talking about. Everybody understand? So the one that's horizontal like this isn't always the adjacent one. It depends which angle to which you're referring. You got it? So this would not be opposite angle beta. What would it be? To angle beta, what would this one be? This wouldn't be opposite. This one right here. I'm talking about this side right here. What? I'm not saying theta, beta, B. This is B, beta. Okay, this is adjacent to beta. I shouldn't have used beta because theta and beta sound the same. I get it. All right, but this is beta, B. We'll call it B. All right, so this is adjacent to B, and this one is opposite of B. This one is opposite of theta, and this was adjacent to theta. What never changed? Hypotenuse. Because the hypotenuse is always what? Opposite the right angle. Okay? Everybody with me on that? All right, enough of that. So now what we're going to do is we're going to come up with some ratios. We're going to compare two of the sides to each other. All right? Hunter, this is what you need to be paying attention to. This is not the time to fall asleep. Okay? Not the time. Did I? In the other, last year? I was yelling at them. I couldn't imagine me yelling at them. They were such a wonderful class last year. They're probably my most ornery honors class that I've ever had, ever. Last year's class. Anyway, that's probably why you heard me. Yeah. Well, you were in that class last year, so you know what it was like. All right. Let's do this. So we have 3 words to describe the ratio. What we're going to do is we're going to compare 2 sides to each other. All right. And the first one, I'm going to compare the opposite side to the hypotenuse. All right. And we have a word for that. So here are the words. When you compare the opposite side to the hypotenuse, we have a word for it, and we use the word sine, and it's spelled S-I-N-E. The sine of what, though? It all depends what angle we're talking about, because I don't know which one's opposite, because I got to know which angle I'm dealing with. So if I'm dealing with angle theta, then which one is the opposite? This one. Which one is the hypotenuse? Well, it's always going to be that one no matter what. Okay? Everybody with me on that? Let's get rid of this so we just don't get confused of that one. All right? Get rid of that circle now, and let's get rid of that. All right. I'm going to show you a shortcut. Instead of writing S-I-N-E, there's a shortcut, but we're going to do that in a second. And then you have another one, another ratio. This time, we're not going to compare the opposite to the adjacent. To the hypotenuse. We're going to compare the adjacent to the hypotenuse. All right? Hypotenuse. All right. And we call this the cosine. And again, what angle? You're not just going to say the cosine equals. It's always the cosine of an angle, because it all depends on which angle you're talking about. Because the adjacent side, right, depends on which angle that you're dealing with. So if I'm dealing with this angle, this is my adjacent side. If I was dealing with this angle up here, then this would be the adjacent side. All right, so it really matters which angle you're talking about. And we have one more. Now there's actually 6 altogether. If we wanted to make every single combination possible, there's actually 6 of them. We're only going to be talking about 3 of them. All right, and this one, now these already compared 2 things to the hypotenuse, so now we have to compare the other 2. What's left over? We can't compare to the hypotenuse now because I've already compared the opposite. I've compared the adjacent to the hypotenuse. Now I have to compare the opposite and the adjacent to each other, okay? And the order that we're going to compare them is what I just said, the opposite over the adjacent. All right, so all this is, we're just comparing 2 sides. We're making up a fraction is really what we're doing. And we use a word that we've used once before when we talked about circles, and we use the word tangent. And I used to say that this tangent has nothing to do with the tangent that we learned earlier, right? About a line hitting the circle at one point. But I just watched a video, maybe a week or 2, maybe a couple weeks ago. I watched a video, and the guy talked about, and it was a great graphing program that he used. It was really, really cool. I'll have to look for it and show it to you once we start doing some more trig. So once the trig gets a little more familiar to you, I'll try to find that video and show it to you. To me, it was really cool. But there's definitely a relationship between this tangent and the tangent that we learned when we talked about circles. Remember what the tangent was? It was a line that just hits a circle at one point, doesn't go through it, right? It just kind of skims right off of it. Yeah. So there is definitely a relationship. For years and years and years, my whole entire math life until a few weeks ago, right? I didn't know that that was true. I had a feeling that maybe it was, but I just didn't do any research. But I saw that video and I thought, oh, wow, that's really cool. And there's reasons why they use the word sine and cosine. We're not going to get into it. I'm not going to go into some history lesson with this. But I think on that video too, they talked about that. And that's something that I didn't know. So that's kind of cool. All right. Usually, and it just goes to show you, usually math classes, they don't really, go through the etymology. Do you know what that word is? If I'm saying it right, etymology. It's just like the origin of words, where they come from and stuff like that. All right, so what we're going to do is we're going to shorten this a little bit. So watch, I'm going to put sine as just S-I-N. We're just going to use the first 3 letters. Now, we don't say what? We don't say sin, we say sine. And it's not because, sin means it's something bad, blah, blah, blah. It has nothing to do with that. We just don't say it that way. We just say sine, all right? But we always write it. When we write it, we don't write out the whole word, all right? We just shorten it up with the first three letters. Just makes it a little easier to write. So the sine is equal to what? Opposite over hypotenuse. Now I'm going to do something here for a reason, okay? I'm going to show you kind of an easy way to remember these three ratios, because sometimes they can get confusing. So I'm going to give you a little mnemonic device. There's a word. I think I might have used that earlier in the year. Do you know what the word mnemonic device means? It's basically you're taking the first, you're taking like the first letters and you're making a word out of it. Right, that's what I'm saying. I said yes. I agreed with you. So that's what we're going to do here. So the sine is equal to opposite over the what? Hypotenuse. And then the cosine of the angle, we're just going to use cos. Again, we don't say cos. I've heard people say that, but we don't normally do it, okay? Let's say cosine, all right? So you're not going to say cos. You're not going to say sin. You're not going to say tan, even though I have heard people say that before. In here, we're going to use the actual words. We're going to say sine, cosine, tangent, all right? And what was the cosine? It was the what? Adjacent over the hypotenuse. Why is my pen acting weird today? I don't know. I don't think I'm pressing hard enough. And then what's the third one? It's the tangent. So I just use TAN for tangent, and that is opposite over what? Adjacent. So now what we're going to do is we're going to come up with a little device. It's not a real word, but it's a word that you can go around saying, and if you say it a few times, you remember it, and it's an easy way to remember your sine, cosine, and tangent, okay? So what we're going to do is we're going to use the S first, so SOH. You understand what that means? The sine equals what? The opposite over the adjacent. Even though those are next to each other, we just have to realize it's over. Everybody got that? So sine is the opposite over the hypotenuse. So how am I going to write the cosine? C what? AH, right? Right? Cosine is what? Adjacent over the hypotenuse. And then lastly what? The tangent is opposite over adjacent. So here's how we say this. Again, it's not a real word. You can say it however you want, I guess. But we say SOHCAHTOA. SOHCAHTOA. All right, so if you put those together, SOHCAHTOA. Everybody say it on three. Ready? 1, 2, 3. SOHCAHTOA. All right, so go around. I always tell students, I don't think they've ever done this, and I don't blame you if you don't. But it could kind of be like your little secret word, right? Your little club word or something. So you go around, see somebody in the hallway, high five them, then SOHCAHTOA, right? SOHCAHTOA. And then people are going to look at you like they're crazy, right? You could have your own handshake and everything and say SOHCAHTOA. And people won't know what you're talking about, except for the people that learned this before, all right? All right, anyway, that's kind of a joke, but if you want to do that, feel free. So SOHCAHTOA, that's what I would remember, SOHCAHTOA. Everybody got it? Okay, don't forget it. Now, when I learned it in high school, my teacher said Toa Soka. He put the T first. And I used to teach that for years and years. And then one of the books I taught out of put SOHCAHTOA in there, right? A lot of books don't put that in there, but this book did. And so instead of being different from the book, then I started teaching SOHCAHTOA. So I'm back to that. I think if you go to most teachers, if they were going to talk about this, they would probably say SOHCAHTOA. So that's why I went back to this. All right? Anyway, there you go. Mr. McDonald was his name. He was a big reason why I became a math teacher, because that's when I really, really started liking math. Would you please stop? And you stop. Thank you. All right. Honors, is that what this class is? Just checking. All right, so example 1. Maybe I should have let you go to sleep, Hunter. Hunter McKenzie on my video. So now it'll last as long as YouTube will last. That'll be on there. All right, here we go. Now, what we're going to do. Now, over here, I put opposite, adjacent, hypotenuse. What do you think we're going to put in there, though? These are going to be what? They're going to be numbers, exactly. All right, so let's put some numbers in. Let's call that 9. Let's call this 5. And let's find this one right here. Okay? So if I give you two sides of a right triangle, you should always be able to find the third side. Let's do it really quick. All right, so Pythagorean theorem. What do you want to, let's call this x. Is that all right? I'll tell you what, let's not call it x. Let's call it letter B, little b. Why little b? Because it's opposite what? Angle B. Everybody got that? All right, and then we'll call this little c. We'll call this what? Little a. All right? Okay, enough of that. So let's do the math. What is it? 5 squared plus b squared. My pen is acting really silly today. B squared equals 9 squared. Yes? All right, let's do it. That's 25 plus b squared, and that's what? 81. Subtract 25 from both sides, and what do you get? 56. Yes? Take the square root. You could keep it the square root of 56, but let's simplify it. 2 goes into this, what? 28 times, right? And then 2 goes into 28, what? 14 times. So that must mean what? 4 times what? 14. Yes? Okay. And then I can take the square root of that. Why did I pick this? Why didn't I just stick with 2 and 28? Because I could take the square root of 4. What's the square root of 4? It's 2. Square root of 14. So that's what this is. It's weird, but that's fine. That's what it is. Those are the numbers they picked. If I was to write the book, I probably would have picked like 3, 4, 5 just to make this super easy for you. But they decided to make it weird. But that's okay. We learned a little bit today. So now what we're going to do is it says state the exact and the decimal approximations of the sine cosine of tangent of angle A. Angle A. So I'm going to put a little arc right there. So that's the angle. That's my theta. Okay. So I want to state the exact values for it. So I'm just going to set up my ratio. All right. So let's do it. Let's go sine of angle A. Let's go cosine of angle A. And let's go what? Tangent of angle A. All right, without cheating, without looking. Oh, got it right here. Let's get rid of that. Okay. Scooch it up a little bit. There we go. Without cheating, let's go through it. It's SOHCAHTOA, correct? Very good. That's how you do it. That's how you use it right there. The sine is the opposite over the hypotenuse. How do we know that? Because it's SO, S-O-H, opposite hypotenuse. Everybody got that? You understand how to use it? All right, so angle A. Which one is opposite of angle A? 5. So that goes on top. Over what? Hypotenuse, which is 9. That's the exact answer right there. They also asked for a decimal answer. Right? So what do we do with this? Put it into a calculator. Exactly right. And it comes out, I shouldn't put an equal sign because it is a what? An approximation. Now, I can put an equal sign here because 5 over 9 is an exact number. All right? But if we put it into a calculator, you get approximately... And for sine, cosine, and tangent, they always want you to do it 4 decimal places, okay? So it's 0.5556, all right? So that would be the decimal approximation. It's just calculator work is all it is. Everybody good? Yeah, this is easy. I mean, this first lesson, super easy. I'm not even going to solve for this angle. In the next lesson, though, I'm actually going to find what that angle is equal to, all right? I wouldn't have been able to do that before this. Like if I just... What's the only way I could have known those angles? I had a 45, 45, or 30, 60, 90, right? That's really the only way I knew anything about these other angles, right? If I know one angle, I can always find the other one, right? Would you agree? All right, but if I have 2 unknown angles, there was no way for us until tomorrow that I could solve for those angles, okay? So we're just working our way up to it. All we're doing is just trying to get you to learn what the ratios are, okay? What the opposite, hypotenuse, hypotenuse, opposite, adjacent, okay? That's all we're trying to learn. Okay, cosine of this angle, of angle A, is equal to what over what? Well, what is the cos, C-A-H? What is that? Adjacent, what? Over hypotenuse. Which one is adjacent? What's adjacent to angle A? 2 squared of 14. So it's 2 squared of 14 over the hypotenuse, which is 9. Does 2 go into 9? Nope. So that's exact. You just keep it like that. That's your exact answer. And if you put it into a calculator, I'll do it for you. It's 0.8315, 4 decimal places. Pretty simple, isn't it? See that trig stuff, it sounds scary, right? Trigonometry, man, it sounds scary. But really, it's not that bad. If you just learn, every day you learn something new about this. At the beginning of it, it's not hard at all. So the tangent, what's the tangent? It's what over what? It's opposite over adjacent. It's TOA, T-O-A, opposite over adjacent. So again, angle A, which one is opposite angle A? 5. And which one is adjacent? 2 square root of 14. Now, we can't keep it like that. Why can we not keep it like that? Very good. I like that. You can't have a square root on the bottom. All right. So how do we, I'm not even going to, I could right now put it into a calculator if I wanted to, but let's fix this. Let's make this so it's simplified. So how do I get rid of that square root of 14? You got it. You remember this. That's good. Makes me happy. Square root of 14 on top and bottom. And what do we get? 5. What's the top? That's easy. 5 what? Square root of 14. And this, what's the square root of 14 times the square root of 14? Easy, without doing any math. It's 14. It's 14. Because what am I doing? I'm multiplying something by itself, correct? So I'm taking a square root, and what am I doing? I'm squaring it. So what does that square do to the square root? It cancels it out. So what am I left with? 14. Let's do this in our head. So it's 2 times what? 14. What's 2 times 14? 28. That right there is the simplified exact answer for the tangent of A. Remember, I'm not finding A just yet. I will tomorrow, okay? I'm going to show you a way to do that, all right? But right now, I'm not solving for A. All I'm finding is what? The tangent of A, the cosine of A, the sine of A. That's all I'm doing right now. But you're going to have to do that tomorrow when we actually solve for the angle. Okay? You with me? All right. And then what do you do with this? You need an approximation, so you put that into a calculator. I've already done it, and it's 0.6682. So that's your approximation. So that's the kind of stuff that they're going to ask you to do. All right? Let's do another one. We've got some time. Any questions on this? Now's time to ask. Yeah, it's not too hard, is it? Let's do another one. This is example 2. And let's draw the triangle, the right triangle. It's not necessarily to scale. I don't really care about the scale of it. I just care about the numbers. So this is A, this is B, and this is C. All right, and remember I said if it was me doing it, I would have used a 3, 4, 5 triangle. Well, guess what they're doing here? Yeah, all right. But let's pretend we don't know this side right there. We know what it is, don't we? All right, let's pretend we don't know what it is. All right, so what would I call it? What letter would I call it? A, little a, right? That's a weird looking C there, isn't it? Let's make that look a little nicer. There we go. All right, so here's the question. It says, given acute angle A, well, we know angle A has got to be acute because these two, on a right triangle, the other two angles are always acute angles anyway. So given angle A such that, this is what they tell you, watch. This one's kind of easy because you know it's a 3, 4, 5 triangle, but they're not always going to give you 3, 4, 5 triangles, okay? They're going to give you some weird numbers, all right? So you got to understand what's going on here. So they give you that the cosine of A is equal to, actually, you know what? I'm sorry. I should have done this. Let's say you don't know any of those. Okay? I wrote it on my example, but it probably starts off. Anybody got the book open? Example 2. Does it start off with no? It just starts with nothing, right? Yeah. So they just tell you that the cosine of A is 3 over 5. Why do they do that? Because what is the 3? 3 is the what? Is it opposite, hypotenuse, adjacent? What is it? It's adjacent. That's right, because it's cosine. What's the cosine? CAH, adjacent over hypotenuse, right? So this is adjacent, and this is what? The hypotenuse. So that helps me fill in my little triangle, doesn't it? All right? I just did it a little premature on when I wrote those things down. So that means here's angle A. Which one is adjacent to angle A? The AC right there. So how much is that? That's 3. Hypotenuse is AB, obviously. And so that's what? That's 5. All right? So now I can do some math and I can figure out what BC is. We could do it easy because it's a 3 what? 4, 5 triangle. It's not always going to be that easy. Sometimes you might have to do some Pythagorean theorem like we did on the first example. Agreed? All right, so there's our triangle. So the question is, we want to find now what is the sine of A and what is the tangent of A. So what is the sine of A then? So I know all 3 sides. What's the sine? What letters? Sine is opposite over hypotenuse, right? O and H, right? All right, SOH. So it's opposite over hypotenuse. So which one is opposite angle A? 4. Which one is the hypotenuse? It's 5. Okay, tangent is what over what? Opposite over adjacent. That's right. So angle A, which one's opposite? 4, just like it was before. But which one's adjacent though? 3 is adjacent. And there you go. That's all they're asking in this right here. In the next lesson, okay, what are we going to be finding? I'm going to actually be finding what that angle is actually equal to. And once I find one of those angles, the other one's super easy. How could I find the other one? That's it, 90 minus whatever that angle happens to be, okay? Simone?
If they tell us to put it in a calculator, no, I mean
to find the angle? Yeah. We're not going to yet. Tomorrow I'll show you.
Oh, what do you mean like a decimal?
Oh, on it. Well, you just put 4 over 5.
No, I mean on where it says.
Like what I did here? Like right here?
No, it's like example like this, and it's in our homework.
Bring it up to me. Let me see it. Which ones? Oh, okay. Gotcha. Yeah, I didn't put that on my notes. That was dumb. Give me one of those. Let's do actually one of those. Oh, there is an example 3?
Yeah.
I did not put example 3 on here. That's dumb. All right, give me what example 3 says. Sine of what? 30 degrees. Okay, give me the other ones. 22.75 degrees. Is there another one? That's it? Okay. So, good question. I don't know why I didn't have my in my notes. I have to do that. We got 1 minute. So let me bring up my calculator. Now, it depends on what kind of calculator you have. All right. Let's turn that on. Let me go to this. Let's turn it to calculator. And does it show up? I thought it showed. I don't know if that shows up or not. Well, I only got a minute left. I can't mess with that. So I'm just going to do this. So the sine of 30. On a calculator like this, you would actually hit the sine button. See the sine button right there? All right. And then you just put 30. And then, boom, there it is. Okay. Oh, you know what I forgot to do? I forgot to do this. On this calculator, you probably don't have to do this. But on my calculator, I have to change it. Oh, to mode. I got to change it. See where this third one where it says radians and degrees? Right now, it's set to radians. What do I need to set it to? Degrees, okay? I got to remember to do that, all right? Yeah, and how do I get out of here? Hit enter. Just enter. Maybe clear. There we go. Now let's try it. Watch. So I hit sine, and then I hit 30. 30, click. There we go. Hit enter. There it is. That's better, okay? So that's how you do it. It's really simple. Now, if you have a calculator like this, all right, it used to be, every calculator was like this, but you would hit 30 first. You'd hit 30. You just put 30, then you'd hit the sine button. So what you need to do tonight, you need to know how your calculator works. Now listen, if you come and take a quiz from me or a test and borrow my calculator may work differently than what your calculator does. Even these little tiny calculators like this. Some of them, you hit 30 first, then sine. All right? Everybody got it? So you got to make sure you know how your calculator works. Okay, that's it.